Hello, IB. We're going to go ahead and do 6G1, which is geometric series. So your last few lessons, you were looking at geometric sequences, and you guys were introduced to the formula for a geometric sequence, which is right here, where u sub n equals u sub 1 multiplied by a common ratio raised to the n minus 1 power. So remember, with a sequence, we separate our terms with commas because we're just listing out the sequence, and we can tell that there is this multiplication of 4 occurring between each of our terms. So therefore, we know that our R value is 4. So now when we look at series, we're just taking those values and adding them together. So one of the ways that you guys will learn how to do this is by using your series formula. And there are 2 different series formulas, just depending on what your ratio is. So we'll look at that in just a minute. The other way, so before I fill that in, what you're really just doing, though, is if I looked at the series sum of the first 4 terms, I'd be taking 2 plus 8 plus 32 and plus 128. And therefore, we're looking at a total of 170 for our series. Or you might look at it as sigma notation, where, all right, if I know my first term is 2, so I'm going to use this formula from last class for a sequence, u sub 1 multiplied by your ratio raised to the n minus 1 power. So I'll take 2 as my first term. My common ratio is 4 raised to the n minus 1 power, so that n is going to consistently change. Remember, n starts with 1, and we have 4 terms here, so we're going to end on 4. So again, if I wind up using this formula, I still come out to 2 plus 8 plus 32 and plus 128 if I substitute in n as 1, 2, 3, and then 4. So again, I know how to do this for a short number of terms, but if you ask me to do this for 50 or 100, there's no way I'm going to wind up doing it this way. So similar with arithmetic series, we had a formula that basically is derived from looking at the expansion of several terms, and we come up with this first option here, s sub n, where your first term is multiplied by r to the n minus 1 divided by r minus 1, or the second formula, which is the reverse order basically, 1 minus your r to the n power and 1 minus your r. So this first series for geometric for geometric series, the first formula here is when r is going to be greater than 1 or where r is less than 1. So just think about what's going to happen there. So basically, if your r value is a positive or negative integer other than 1. If you look at this closely, though, there's no way that we're allowed to have an r value of 1. Otherwise, we'd be dividing by 0. All right, so notice one of our caveats here is that our restriction is that r cannot equal 1. So r will never equal 1, otherwise we're not going to have an actual ratio. But if you guys are looking at this, r is greater than 1 or r is less than 1, we'll use this first one. And the second formula here is for when r is between negative 1 and positive 1. So when you're looking at a fraction, a decimal between negative 1 and 1, okay? So those are our 2 formulas. Your textbook also shows you guys the proof of how these formulas are derived, and we will go through that with you guys in class. So if you'd like to take a close look at where this actually comes from, we've expanded your series and just started to put together, there's a similar question, number 5 in arithmetic series problems just a few days ago that we went through with you guys, and we'll spend a little bit of time on this one as well in class. But if you'd like to pause here and try to work through it and get a sense of where this came from, you're welcome to go ahead and take a look. So taking a closer look at this example that we started with, the series began with 2, 8, 32, 128 all being added together, and we're going to let that continue a little bit further for this next example. So if I just wanted to set up my general formula for the sum of n terms, so I'm not sure how many terms we're going to go out to first, let's go back and take a look. We realize that we do have this multiplication of 4, so with a ratio of 4, let's go back and double check. We'll wind up using this first formula. So let's go ahead and set that out first. You always want to have your first line of working the formula that you're going to use. So now with our formula set out, we'll go ahead and substitute in the values that we're familiar with and that we know from the series that's given to us. U sub 1 is our 2. Your ratio is 4, so 4 to the n minus 1. And then in my denominator, I have my ratio, so 4 minus 1. All right? So I can clean that up just a little bit. So 2, got 4 to the n minus 1 in brackets, and then 3 as my denominator. So now I'm ready to go ahead and find, because this is the series sum for any amount of terms. So let's go ahead and see what the sum would be for 10 terms. So substituting in n is 10. Remember that small subscript is your n value, how many terms you have. So 2 is my first term, my u sub 1. I have 4 raised to the 10th power minus 1, all divided by 3. And remember, I must find my, I must simplify my numerator before I divide by 3. Or you can think of it as 2/3 times 4 to the 10th minus 1. But please make sure you're following your order of operations to correctly get to your final answer. So my final answer for this one is 699,050 for the sum of the first 10 terms in this series. So let's go ahead and take a look at another application that you guys can now use with your series formula. This question is a follow-up from the same series, and it says find the first term for when the sum of however many terms we're discussing is greater than 8,000. All right, so if I'm looking at my summation formula, let's go ahead and write down what that general term, or sorry, the general formula for the summation was. So 2 raised to the 4, 2 times 4 to the n minus 1 divided by 3. So 2 4 to the n minus 1 divided by 3. And I want this to be greater than 800,000 for this series. Okay, so how many terms will I actually wind up needing for the sum to be greater than 800,000? Well, we've already got to look here. For 10 terms, right, it's close to 700,000. So it might need to be more than 10, right? So we're just going to do a little guess and check here, and let's see if we can actually prove it. So going back to my basics on how to solve an inequality, if I can multiply out both sides by 3/2, all right, that will reduce this fraction. So I can just look at the 4 to the n minus 1. So let's multiply both sides by 3/2. And you guys are left with, 4 to the n minus 1 is greater than. All right, 1,200,000. I'm going to go ahead and add 1 to both sides. So I'll have 4 to the n is greater than 1,200,001. And now that we've done our log chapter, I can actually rewrite so I can isolate my n using logs. So just changing from exponential form to logarithmic form. And now I wind up, if I evaluate this log base 4 of 1,200,001, I get about 10.0973, and that will continue. So remember though, n has to be an element of your positive integers. So if n, because n is the position of the term in your series, I can't have n be a decimal. So if n has to be greater than 10 point something, basically n is going to have to be at least 11. All right, so if n is 11, then my sum will actually be greater than 800,000. So it says find the first term for when the sum is greater than 800,000. So 11th term would be the first term where that would happen. And then of course 12 terms, 13 terms, and so on would also give you a total for your series to be greater than 800,000 as well. So let's just think about some other ways that we can actually solve this. If I don't do it algebraically, notice any single time you're trying to find an intersection or an inequality where one function might be greater than or less than another, I really have two separate functions. So I could look at this series as my f of x sub 1, right, my first one, and I could look at the second one as a second function. So let's go ahead and use our calculator to graphically solve this equation. So setting up our calculator to put in our first function as 2 times 4 to the n minus 1 divided by 3, since that's my S of n formula. And then my second function would be 800,000, and I'm looking for the intersection. And I also want to then, once I find the intersection, I'll want to find when this 800,000 is actually less than this series formula. So let's go ahead to our calculator and put both of those in and see what we find. There's function 1. In order to see my second function, I had to zoom out a bit, and already here I've got my intersection. So if I want to know when my sum is greater than 8,000, I'm looking right here, and the only time that my sum is going to be greater than 8,000, remember this is my sum formula, this red line is my 8,000, so it's going to have to be after this point right here, which is after that point of intersection, which is that 10.09, blah, 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 blah. So after that value, which my next integer is 11, I'll go ahead and accept that as my answer. Okay, so visually, graphically, you guys can support your answer algebraically. Just depending on whether you're allowed to use your calculator or not, always be thinking about how that calculator can help you. All right, guys, and last but not least, go ahead and try to evaluate this geometric series. When we did sigma notation, we had a couple geometric series questions mixed in with that section. So now that we've actually discussed geometric series, we can go back and try some of these sigma notation questions. So of course, we know that if we just stick it straight in our calculator, one method, of course, we can get our answer that way. So 3,069 if you guys use sigma notation in your calculator. Another method is actually to substitute in all the values. So if I actually wind up substituting in k is 1, so 1 minus 1 plus, and then k is going to be 2 plus, and I continue. I could also get my last term, 3 times 2 to the 10 minus 1, and then I can get my 3,069 that way. And then last but not least, now that we know this summation formula for the first 10 terms, I can talk about my first term. So my first term is that u sub 1, because remember this is your u sub 1, this is your r raised to the n minus 1 or k minus 1, whatever letter you're using. So we're going to go ahead and use my first term, which is 3, multiplied by my ratio, which is 2, raised to the, we'll use n or k, doesn't matter, but minus 1. Since my ratio is greater than 1, I'm using the r minus 1, the same one that we used on this one, the r minus 1 formula. So 2 minus 1. And whoops, I'm going to take away that n because now I actually want to find the sum of 10 terms for my series. And I can get 3,069 that way as well if I just substitute that or place that into my calculator, simplify, or by hand. So that is what you guys are expected to be able to do with these geometric series. All right, a little bit of everything put together, sigma notation, your formula, your calculator. See you guys later. Have a good night.